When we're talking about the conversion of ATP to ADP, here's the full ATP molecule up here, and here's ADP plus the phosphate formed. The process also involves a water molecule and a basic site on an enzyme that I'm emphasizing here with B. Overall in this process, it is exothermic, although there are definitely bonds broken. In particular, this O phosphorus bond is broken. This HO bond is broken, and this HO bond is broken. But at the same time, there are three new bonds formed. An HO bond over here between what was this oxygen and one of the hydrogens that came from water. A phosphorus-oxygen bond right here, which is between phosphorus and the oxygen in this water. And a basic site on the enzyme accepts one of the H pluses. So 3 bonds are broken in red and 3 bonds are formed in green. The fact that this whole process is exothermic by 30 kilojoules per mole tells you that the bonds formed give off more energy than the bonds broken cost. In other words, we're investing energy to break bonds, but in exchange we get additional energy back to make bonds. And the difference between the energy it costs to break these 3 bonds and that you get back from making these 3 new bonds is 30 kilojoules per mole. Now let's look a little bit at which bonds are broken and what they might cost. Okay, so an HO bond costs about the same as an HO bond at the end. In other words, you neither gain nor lose. An HO bond costs close to the same as a basic site on an enzyme to H bond. So the big difference here is the phosphorus-oxygen bond that is broken here costs a lot less to break than you get back from the phosphorus-oxygen bond here. In other words, this phosphorus-oxygen bond is much stronger than this one is. There's a number of reasons for this, one of which is that the whole phosphoanhydride, POP, orientation is unstable, partially due to all the negative charges repelling each other. That's relieved when you cleave off one phosphate. Another reason has to do with this oxygen has some resonance interaction with both sides with phosphorus, whereas this one has only resonance interaction with one side with phosphorus, making it a stronger bond. But in either case, the difference in strength between this bond and what it costs to break and this bond and what it costs to make is very close to the entire energy change of 30 kilojoules per mole.